right, it is 4:10 Eastern Time. Thank you to all of you who've joined this session. Welcome. Thanks for hanging in with us to this point in the day as well. Um, it's my pleasure to introduce to you Dr. Michael Orosz from University of Southern California Information Science Institute, and he'll be presenting updates on his research task, WRT-1012, Global Positioning Systems, Mission Engineering, and Integration of Emerging Technologies. So with that, I turn it over to you, Dr. Orosz.
Well, thank you, Jordan, and good afternoon, everybody. So the outline is a little bit about what the project is, our test environment, some of the results up to now, a little bit of discussion about the results, and then finally some next steps on a future project. So, this was all animated, but unfortunately, animation is not working today, so you get bland slides. But here's the project. We're basically targeting the space-based system acquisition process. No surprise, given that we're funded by basically the Space Force, United States Space Force, and our goal is to improve the acquisition process by introducing agile and SecDevOps processes into what is traditionally a waterfall environment. And I just want to state up front, it's not that waterfall is inherently bad. It's just that for certain types of acquisition projects, agile is a much more preferred way of going. If you have, say, dynamic requirements, or you need to refine requirements through the project, or you have heavy user engagement, and that engagement is required in order to produce the product, then agile is really ideal. But if you're building an aircraft carrier, waterfall is probably the preferred way to go. In addition to introducing agile and monitoring performance, our goal is also to develop training tools, educational tools to help the workforce, particularly the government workforce, transition from, again, the waterfall DoD 5000 standards into a much more agile DevSecOps environment. Okay, so the process. So first, we need to understand the current acquisition environment. And the way we do that is we actually become part of the environment. So a number of my colleagues are actually on this teleconference, and we're part of the team. We are involved in the acquisition process. We go to all the meetings. We collect data. It's the best way to collect data. We're developing tools to help us collect that data, because a lot of this information is difficult to extract from either the government sector or from the prime contractor's side of the house. And so we are part of that team. We're not just observing from the outside, and that really does afford us a nice opportunity to become, integrated into this system and see what's working, what's not working. And again, looking for develop approaches, suggestions, recommendations, lessons learned on how to integrate agile and DevSecOps into the DoD 5000 or into a waterfall environment, and also develop those lessons learned, and most importantly, to take those lessons and transition them to other processes, not necessarily even in the space-based acquisition environment, but other major DoD environments where there's it's a large acquisition environment. Okay, and I'm doing everything by manual, so even my screen scrolling isn't working. Apologies. So our project overview, our partners, of course, are CERC, and then we're, again, the Information Sciences Institute, and just a little bit aside, we're part of the School of Engineering at USC here in the Los Angeles area, and we're headquartered in Marina del Rey, not too far away from the funding agency, which is just down the block from us. And we're also partnered with Georgia Tech Research Institute. Again, funding is from the Space Corps, or the Space Force, and it's actually via the System and Missile Center's Production Corps. And our project's coming to an end, Christmas Day coming up in about a month. The good news is that we are in the process of completing the contractual agreements to start the next follow-on project on a similar program, and we'll talk a little more about that at the end of this presentation. Okay, excuse me, I'm having trouble with my screen here. Okay, there we go. All right. So the test environment. We have two separate software projects that we're going to talk about up front. Project A is a traditional waterfall project. It's about 39 months in duration, which, as it says here, includes a schedule extension. And the software lines of code, or SLOC, is about 180,000 lines of code. So it's a reasonable size project. Project B is a hybrid composed of both waterfall and agile components. So there's actually two efforts that were undertaken in parallel and integrated throughout the project. And it's shorter. It's about 25 months in length and about 115,000 lines of code. So a little bit smaller, but roughly the same complexity. In fact, they're off of a common sustainable platform. So they're very similar in capability, complexity, skill sets that are required to understand the system. So it's a nice A/B comparison that we can work with. So our approach to analyzing the performance of Agile versus Waterfall, normally when you're looking at Agile, you're looking at a number of factors. You're looking at the ability to incorporate changing requirements or priorities, the ability to incorporate user feedback, and also to measure how well your integration is going and how you can reduce the number of problem reports or errors, bugs that are discovered during integration and testing. In this project, because the requirements are so well defined for both Project A and Project B, the opportunity to change requirements midstream were slim, and they didn't happen. In addition, user interaction to provide feedback on what's working and what's not was not possible due to the nature of the project. So really the only thing we could track to see what is improved or not improved by adding Agile into the development framework is problem reports. And as many of you know, in a traditional waterfall development effort, most of your PRs are discovered towards the end of the development cycle, where you start to do your integration and testing. Because prior to that, you're developing code and you're doing unit testing. You may have some small scale integration and testing going on, but the large integration and testing efforts are usually left at the end. And so you get a bow wave of PRs that usually means an extension of the schedule and or costs that grow in order to address those issues. So that's what we're tracking here. Can we reduce that bow wave of PRs? And so every week we would collect PRs from the different projects and store them. And these PR counts, and you'll see this in the upcoming slide, are plotted on a line chart to compare the development history of the two efforts. Now, as we noted earlier, Project A is a little bit bigger and a bit longer than Project B. So in order to compare apples to apples, we just simply slid the two curves, if you will, on top of each other so that the FQT, the final formal qualification testing date, coincides. Again, because these are similar projects, similar complexities, we felt that this was a nice, easy way of doing apples to apples in terms of comparisons. In addition, because Project A was about 60,000 lines of code larger, what we did is we proportionally reduced the bug or PR counts accordingly, so that we're looking at PR counts for Project A versus Project B based on roughly 115,000 lines of code. Yes, there's it's not a perfect match, but it's reasonably close, given that both projects are reasonably the same in terms of complexity and skill sets required. So with that, I'll show you the line chart. And so this graph, the upper line, which is roughly green or olive, depending on your monitor, that's the traces of problem reports across the whole project for Project A, which is the traditional waterfall effort. Notice that there are two peaks in that error curve. The lower graph or trace, which is roughly yellow or golden color, is our Project B, which is the hybrid project. It's a combination, again, waterfall and agile. And in the blue trace is the difference between the two traces, the delta. Notice just from this chart that there's definitely, again, looking at apples and apples, the Project B, which incorporates agile, definitely had lower numbers of PRs throughout the life cycle of the project, and particularly towards the end of the project, where a lot of the integration and testing gets done in a traditional waterfall effort. So go to the next slide, which adds a little more detail. This is exactly the same chart that we just saw, except we've broken out the problem reports for the agile portion of Project B only. It's at the very bottom of the graph. It's sort of a bluish green or dark blue trace. It's barely noticeable compared to the other traces. And so just visually, it's pretty obvious that, at least in this project, agile is producing very few PRs that need to be addressed towards the end of the project. So right off the bat, it looks pretty promising. And then further, we take Project B only. So this is only Project B, and we divide it between the waterfall portion and the agile portion. So the upper trace in roughly brown color, that's the problem reports recorded for the waterfall portion of the effort, and the, again, dark blue or bluish green trace at the bottom is only for the agile portion. Now, a couple of things to know, and it's in the legend there. The waterfall component has roughly 49% of the software lines of code, while the agile portion has 51% of the software lines of code. So they're roughly equivalent in terms of effort. They're roughly equivalent in terms of complexity. But the agile effort started 10 months later. And even starting 10 months later, still remarkable results in terms of reducing the PR count during the effort of the program. So some observations. Okay. So one, overall, the PRs are lower for Project B, which is that hybrid effort, than Project A, which is the waterfall. Why? Well, first, that Project A, remember we had those two peaks towards the end of the effort. This reflected a situation which is actually, I mean, not every project exhibits this in the waterfall world, but a lot of them do, where there were so many PRs that were developed or discovered during the CIT process, which is the component integration and testing portion of the effort, that basically testing had to stop, and the team had to go and address all those PRs and then restart the component integration and testing effort to finish out the project. And so we got two bow waves of PRs on this effort, which result in stretching the project out and thus adding more costs to the overall effort. Okay. Observation 2, the waterfall and agile teams worked in parallel for Project B, again, the hybrid effort, and there were periodic merges that underwent integration and testing. I'll show this in a graph coming up, but instead of just one release from the waterfall team, they had 8 releases. So they're almost starting to, change their waterfall method into an agile, because it's not just one release. There were 8 of them, And that definitely helped reduce some of that bow wave that you typically get. We still got the bow wave, but it's nowhere near as great as what we saw in Project A. Project B, again, the Agile team was constantly undergoing or undertaking integration and testing efforts throughout the development efforts. So they had 2-week sprints, sometimes 3-week sprints. Those sprints, at the end of each sprint, there's an integration and testing component. So throughout the whole effort, there was really close to continuous integration and testing of the software. So this clearly contributed to the reduction of PRs that resulted throughout the development of the project. So here's the animation works better. The top orange colored timeline, that's your sustainability baseline. Project B is built off an existing platform, and so there are periodic updates to the base code that has to be incorporated into the system. So the first purple bar you see, the timeline, that's their waterfall effort. And so there were 3 merge events that occurred with the waterfall effort. But note again that there was a build 1, a build 2, a build 8 in the waterfall effort that was subjected to integration and testing, and therefore, again, sort of the beginnings of an agile approach to waterfall, breaking up their development cycle into 8 bites or chunks. And then below that, in the second blue timeline, is the agile effort. And that was divided into 4 major releases, which also was integrated down on the CIT conduit. But again, that gold box there, it says, frequent INT involving virtual interfaces and simulations of components, really helped reduce the agile PR counts versus the waterfall approach, which again, better than what Project A did, but we still had a bow wave of PRs that were generated towards the end of the project. Observation 4. In Project B, the technical complexity of the waterfall components compared to the agile components was roughly the same. So again, referring back to the earlier chart, roughly half of the lines of code in the project were developed under waterfall, and the other half were developed under agile. And again, the complexity of both development efforts were roughly the same. In Project B, however, in the agile portion of it, the experience level of the team was much less that of the waterfall team members. In fact, the waterfall team members had actually developed a lot of the code in the original Project A that had those 2 PR peaks. And so they were very experienced with the system, very experienced with the software, very experienced with waterfall methodologies, while the agile team had the leadership was very seasoned, but the scrum teams were predominantly new graduates. And so observation 6, that even though they had a less experienced team, started 10 months later, they still produced very few PRs throughout the development cycle that needed to be addressed at the end of the project. So very, very good results at this point. So conclusion, clearly with at least these 2 projects, the introduction of Agile and DevSecOps reduced PRs and helped keep the schedule and costs from growing. But some notes, we only have 2 projects here. And as noted earlier this morning in the keynote, the Air Force has really taken a step out there and trying to integrate Agile and DevSecOps and other methodologies into the acquisition cycle. But it's still new, it's still fresh. There's still a considerable number of projects out there that are still done the old-fashioned way. And again, we only have data from these 2 data points. So we need more. Second observation, there's limited user engagement to influence the future Agile builds. Again, I just want to stress that because of the nature of the project, getting end users involved is difficult. And so it would have been nice, even with the Agile part of it, if we could have got some of the users to use those releases when they became available much earlier than after the development is over with. So something that we don't have a lot of experience with yet, at least with this customer, something that we want to get some experience with. And then finally, I want to make it very clear, the reduction in PRs that resulted or were realized in Project B versus Project A clearly were due to Agile, but also we can't ignore the fact that even the waterfall team, they had 8 releases throughout that waterfall effort. So, that definitely helped. There's no way we could say it didn't. It helped, and if you throw the Agile portion of it, it greatly helped to reduce the number of PRs in Project B. So again, some observations, some things to look for in the next go around. So the next steps, which is called Project C. And this is what our follow-on effort's going to be focused on. So Project C, from the outset, is really focused on the Agile DevSecOps approach to developing software from the get-go. So that's a great thing. This is going to be a nice experiment to see how this pans out compared to some of the other projects. Project C, Scaled Agile Framework, which is an approach to applying Agile to very large, complex, multi-teamed efforts. It's a framework developed by a company called Scaled Agile out of Boulder, Colorado. The prime contractor is going to use this on the project, and we'll talk a little more about that as we go forward. Again, this project is enhancing an existing platform that was developed using Waterfall. But again, we're in Project C, we're looking at introducing as much Agile and DevSecOps as we can. And like the hybrid project, this new project, Project C, even though it's going to be implemented in Agile or pretty much in Agile, it still fits in the old framework, the old Waterfall framework. So there's, the enterprise still has measurements like, software lines of code and PR work-offs or burn-offs that are tracked. And so we need to somehow, fit within that framework, still remain as agile as possible. But again, get the necessary information metrics, performance metrics up through the command so that they have a way of tracking the project. So we're going to start the initial focus on developing, basically Rosetta Stones to help train the government side as to how, what is Agile and how does it relate to Waterfall. And so, for example, what's a project backlog? What's a sprint? What's a scrum master, a product owner? What are scrum of scrums? And how do those relate to what was traditionally done under Waterfall? What's a user story? What's a feature? In Scaled Agile, they use an artifact called product increments. What does that mean? How does that relate to traditional Waterfall efforts? And so there's this currently and will be ongoing for at least another 6 to 8 months, this indoctrination of how to, what is Agile and how does it fit within the context of how we measure software development in the current acquisition environment. And here's an example of how we're trying to do this, communicate this. Above is the traditional Waterfall timeline with all the necessary milestones and deliverables and key events, and then down below just a snippet of how to translate. Like a CDD, which is basically your requirements, or they're the same, whether you're talking Waterfall or Agile. But PDR, there really isn't a PDR on the Agile side. there's the equivalent. There's a roadmap. There's a product or project backlog. The architecture is defined in modeling-based system engineering tools, etc. So it's there. It's just not called a PDR, and there's not really an official sign-off. There's more of lots of reviews that are undertaken to ensure that we at least have a decent roadmap on where we're going. There's no CDR. Again, we just take the roadmap and the project backlog, and you continue to refine it as you move into the milestone B and beyond. Milestone B, project backlog is sufficiently populated to meet the roadmap. It doesn't mean the project backlog is completely filled. It's getting there, but it's sufficiently filled that the key deliverables in the roadmap, we at least have a way to get there. And then finally, some of the TRRs and FQTs, which typically happen at the end of a waterfall effort, they occur at the end of each capability release, and I'll get to that in a minute, what capability release is. So, and again, training. So there's ramp up time on this project C. The customer as well, or the customer, the prime contractor and the government have undergone some training. There's some initial work being done for the program, and it's already, they're already introducing, agile artifacts like sprints, scrum meetings, daily scrums, etc. And so we are now part of that. We're doing a lot of brown bagging to, again, introduce the concept to the government. And then finally, customer engagement. This is probably the critical part of this, I think, personally, and that is the government team has to become part of the development team. We need to be at those Scrum meetings if possible. Some of this is not logistically possible, but with Zoom for Gov and some of the other secure video systems, it's possible to be in a lot of them. And we definitely have to be in the planning portions of those scrums and our program increments, and definitely there for the reviews and the demonstrations. We need to be part of that team. One, to help the team, the government team, better understand Agile and how it's being used, but also to help the prime contractor executing an Agile framework. And then finally, the last two slides are an example of some of the training materials that we're using. Again, the top element there is your traditional waterfall timeline, and we're explaining that let's look at the timeline as something like the system development V, which many of you are familiar with. So we'll just call that the V, and as everyone pretty much knows, in waterfall you really don't get capability until you're at the end of the project. There's very little opportunity to make changes in the middle, etc. Again, this is a training slide that we're using with some of our government customers. And then, again, another slide. What we're doing is we're explaining that for this particular project C, we're taking that development and INT portion of the timeline, and we're dividing it up into these little system Vs, these little software development or system development Vs. And we call each one of those a program increment. And they really are standalone, because at the end of each of those program increments, there is a capability, or at least a partial capability, that can be tested, demonstrated, and in some cases even releasable. Now, that may not happen in Project C, but it'll at least be to a point where we can demonstrate that technology to the end user community and get their feedback and roll it into the next program increment. So this is a way of trying to explain to our government colleagues the difference between traditional waterfall, the integration and testing that comes at the end of development, versus these series of small mini Vs, if you will, where at the end of each of these mini Vs is a capability that's deliverable to the customer. So in conclusion, good results two projects that we worked with. One, totally waterfall, had lots of PRs, exhibited the traditional bow waves of PRs that develop at the end of a development cycle. Project B, the second project, much lower numbers of PRs, most of that attributed to portions of the project being developed with Agile, but also the waterfall side of it broke up for development into some mini waterfall elements. And so that clearly helped with reducing PRs. And now Project C, which is really going to go full bore with as much Agile and DevSecOps as it can in order to get the job done and also meet the performance requirements and reporting requirements required by the government. And so with that, I'm at the end of my presentation. Happy to take questions. Thank you.
Thank you so much, Dr. Orosz. We have about 10 minutes, 9 minutes, I guess, now left for questions. And you have a couple questions in the queue. If you're in the audience and you've got a question on your mind, you've got plenty of time to get it in. So both of our questions are from Beth Wilson. Our first question is, in looking at the PRs between the two programs, did you have a sense of the complexity of the PRs? So the complexity of the PRs themselves, you talked about the complexity of the projects. And she says that she would expect the PRs in Agile to be related to the minimally viable product release in the sprint, and therefore less complex. Was that the case?
That is true, because a lot of the complex PRs that you would see towards the end of development, that gets ironed out up front. In many cases, those PRs are a combination of a number of different, in this case, features that may contribute to an overall capability that generates a very complex PR that you find in waterfall. If you break that capability up into features and you're working those features up front in various sprint activities where those efforts are simpler, you'll generate, in theory, and we did see this, simpler PRs to work off. And so you're right. Most of those PRs that did show up towards the end of the development were less complex because we had more time to work on the components that led to that PR up front in the development cycle.
Great, thank you. So this next question appears to be related. And so Beth's next question is, did you find that the PRs closed sooner in Agile? And she says that she would agree that the bow wave would impact the schedule, but would also expect the Agile teams to have better communication and be able to address the PRs quicker. And I suppose that maybe that's a little bit intertwined with them being simpler as well, and separating the effectiveness of the team from the complexity of the PR may be challenging. But
yes, and that goes back to, again, in Agile, you're almost doing constant integration and testing. I mean, within a sprint, there's days, where you're developing software and you're doing unit testing. You're not necessarily doing integration and testing. And so the integration and testing, you have a team of 8, say, or 9 members of your Scrum team. They're going to be talking to each other. And because there's frequent, particularly at the end of a sprint, there's an INT effort, you're talking to other components, other system components, even development members over on the waterfall side. There was communications between the two different threads, if you will, or efforts through the project. So yeah, there's more communication, interaction. Simulators had to be available up front. Sometimes in waterfall, you can kind of wait towards the end before you have simulators in order to do some of the integration and testing. With Agile, you really need them up front if you're going to do that. And I recognize that's a problem in itself, ensuring you have adequate simulation and testing equipment. So I think all those, which are inherent in Agile, really help to, 1, reduce that bow wave, and 2, reduce the complexity of the PRs generated. But good questions. I mean, I actually didn't think about that. So these are good questions.
Yeah, thank you, Beth Wilson, for those questions. We do have several more minutes of Q&A time before we have to jump out of this session. So if anyone has questions, please go ahead and submit them. We'll wait a couple minutes or a minute or two for those questions, and if we don't see any, then we'll just end the session a little early. Okay, we did get another question from Beth again. Thank you so much. She asks, did you look at any acceptance test-driven development techniques?
Not on Project A or Project B, but we will be in Project C. So that very good question too. The acceptance test. Right now, we're actually involved in a study that's ramping up for Project C, and acceptance testing is a big issue. Not ready or prepared to talk too much about that at this point, but we did not dig into those details on Project A and Project B, and that's actually quite helpful. That's a very helpful question. Yeah, good question. I don't really have an answer for it right now. Make a note of that one too.
And then Jordan, I don't know if you're noticing the chat as well.
No, I was not.
Unfortunately, my presentation is blocking everything.
Sure, yeah, just for you then, Dr. Orosz, Beth says that waterfall testing dumps a lot of chef surprise on the test team. Her more recent comments are that ATDD is very different for systems engineering requirements than TDD for software. And she's got some helpful information from an NDIA presentation. So.
Oh, okay. Well, when I get off of here, I think Brian's on, one of my colleagues, see if he can grab some of those comments.